Okay. Hi, good morning. This is Dr. Yamuna Devi. I am going to present Find S Algorithm under the subject of Introduction to AI and DS. Yeah. Aim of this session is to familiarize students with the concept of Find S Algorithm, and the objectives are describe the concept of Find S Algorithm and describe the various applications of Find S Algorithm. And outcomes of this session is to define the meaning of Find S Algorithm, and we are going to describe some applications of Find S Algorithm, and we are going to summarize the various applications of machine learning. Then coming to the topic Find S Algorithm, it only considers the positive example and neglects negative examples. So for each positive example, the algorithm checks for each attribute in the example. Each and every attribute we are going to compare with the previous data. So Find S algorithm is a basic concept learning algorithm in machine learning. So Find S algorithm is a basic learning algorithm in machine learning. It is very useful and very easy to learn. And Find S algorithm finds the most specific hypothesis that fits all the positive examples. So that's why this algorithm call it as Find S algorithm, which means specific hypothesis. Here we are going to find the most specific hypothesis. It considers only the positive examples and neglects the negative examples. We have to note here that the algorithm considers only those positive training examples, as I said earlier. So here we are going to consider only the positive values, not for the negative examples. So Find S algorithm starts with the most specific hypothesis to generalize hypothesis, and each time it fails to classify and observe positive training data. So Find S algorithm moves from the most specific hypothesis to most general hypothesis, which means Find S algorithm always starts from most specific hypothesis into most general hypothesis. Here we are going to discuss the positive values, that is positive examples only. Here we are going to neglect the negative examples, and it always starts from the most specific hypothesis. And before we are going to discuss about Find S algorithm, first we should know some of the representations we are going to use in this algorithm. So question mark indicates that any value is acceptable for the attribute, and pi indicates that no value is acceptable. The most general hypothesis representation is question mark, and the most specific hypothesis is represented by pi symbol. I repeat, question mark indicates any value is acceptable for the attribute, that is general hypothesis, and pi indicates that no value is acceptable, which means specific hypothesis. The most general hypothesis is represented by question mark, and the most hypothesis is represented by pi symbol. So these are all the representation we are going to consider in Find S algorithm. Here we are having only two indications, that is two representations. One is question mark and another one is pi symbol. Question mark is represented by the general hypothesis, and pi symbol is represented by the most specific hypothesis. Then coming to the steps involved in Find S algorithm. So always Find S algorithm starts with the most hypothesis into general hypothesis, which means the hypothesis will be pi symbol, right? So Find S algorithm starts with the most hypothesis into general hypothesis. Here we have taken the values pi symbol. Next step, take the next example and if it is negative, then no changes occur to the hypothesis. So here we are going to change anything in the example, so leave as it is. Take the example, if it is negative, there is no need to change anything in the example. If the example is positive, we find that our initial hypothesis is too specific. Then we update our current hypothesis to the general condition, right? If it is a negative example, means there is no need to change anything in the hypothesis. If it is a positive value, we are going to change, we are going to compare each and every attributes with the general condition. So keep repeating the steps until all the training examples are complete. After we have completed all the training examples, we will have find the final hypothesis when can use to classify the new examples. So what are the steps here? First, we have to start from the most specific hypothesis into general hypothesis, which means pi symbol. Then taken into the example. If it is a negative example, there is no need to change in the hypothesis. If it is a positive example, we are going to change the hypothesis is too specific and update the current hypothesis to a general condition. So each and every positive value we are going to find the hypothesis and have to compare each and every attributes with the previous example. So have to repeat the steps until we get the training, until all the training examples are complete. After we have completed all the training examples, then find the hypothesis when can use to classify the new examples. Then coming to the example, then consider the following data set having the data which particular seeds are poisonous. So first consider the hypothesis to be a more specific hypothesis. Hence our hypothesis would be pi. So here we are going to consider the most specific hypothesis. What is the symbol we are going to use for specific hypothesis? It is pi. So hence our hypothesis would be pi. So consider the example, consider the data set. Here we are having 7 examples. Here we are having 7 examples. So last column represents the outcome of the example. Last column represents the outcome of the example. So consider the first example. So first we have to take the specific hypothesis and move to the general hypothesis. What is the symbol of the specific hypothesis? It is pi, and general hypothesis will be question mark. So consider the example 1. Consider the example 1. First one, green, hard, no, wrinkled. What is the outcome of the previous one? So here we have the attributes green, hard, no, wrinkled. What will be the outcome of this example is yes, which means positive example. So we have to find the hypothesis for this example. So we see that our initial hypothesis is more specific and we have to generalize it for this example, right? So here we have the specific hypothesis. Here we are going to generalize the given example. So hence the hypothesis becomes H equal to, have to write as it is, green, hard, no, wrinkled, right? Okay, then coming to the next example. So what are the attributes here? Green, hard, yes, smooth, and what will be the outcome of this example is no, which means negative example. So we have to neglect this example. We have to neglect this example and our hypothesis will be the same, which means previous one. So H will be green, hard, no, wrinkled. I repeat, consider the second example. It has a negative outcome. See, the last column will be no. Last column is no. So the example will be the negative example. So we have to neglect this example and have to consider the previous one.